Pleasure to introduce the next speaker. No. What I would like to do is take a bit of a research perspective here, and the title of the presentation is Building an Interoperable Data Ecosystem for Personalized Health Research. So you will see a lot of slides that Peter already showed, but the text I'll be talking to should be a bit different, more on the implementation side, on the research side, on how do we actually make it happen. And I think even my mom can't avoid listening that data will transform healthcare. But the angle I'm taking here is not the how data will transform healthcare, but actually what does it mean on the research side that we're getting there? Why is it different for research? And there's several factors that make personalized health research such an exciting time these days. It starts with we as citizens get much more involved in generating data about ourselves, our own health. You see it every day if you have a fitness tracker. You see all these machines now that start sensing longitudinally your physiological factors. Some people go into quantifying themselves in clinical study. A lot of data capture is electronic. So we're moving away from measuring things in rare distances and collecting data manually to collecting huge amounts of data continuously about all factors of life, down to what Migros knows about your nutrition. So the amount of data that is there is, of course, growing tremendously. And the driver behind the revolution really is, of course, the genome project that allows us to look into our own genome, trying to understand what does it tell us about our development, our disease propensities. And this curve I still find it amazing every time I see it. What it basically says is from 2012, which is not that long ago, where sequencing a human genome was in the hundreds of millions, meaning completely unaffordable. We're now down to a level where sequencing our genome in this country is cheaper than going to the dentist. And that basically means there's no reason why not everybody of us could have a genome if there would be a practical use for it. So the question has inverted. It's more like we can do it. Is it actually informative for clinical care? Is it informative for our health? Now, there's a corollary for me as a researcher at the university, and that means by 2020 we expect that worldwide there's hundreds of millions of human genomes available just because it's so cheap and it can be done. But 80% of this will happen in a healthcare setting. Now, I just recently took office as Vice Rector of Research at the University of Basel, and now looking at it from a research side, that inverts the paradigm. When I studied, there was a lot of data on model organisms, cell culture, things you could do in the test tube. And the closer you went to human, the more sparse the information got, the more complicated things got. But now it's kind of changing in the paradigm. We are collecting huge amounts of data on humans, but making this available again for research is a process which we haven't really worked on in the past. And this process is working very badly. And it's hampered by all kinds of things. So if we want to do competitive research in the future in the life science range, we have to close that cycle. And we can't just stay in the linear process we had in the past. So what we're seeing is a bit of a paradigm change here. And the Swiss Personalized Health Network Initiative is one way to address that problem in getting the link between basic research and healthcare much more tightly, so we can exchange health data for research purposes and then again research leading to new health innovation. So that's my usual Mickey Mouse picture on what we are trying to do. We're trying to break open the discipline-specific silos within hospitals and make the data available patient-centric, not billing-centric or discipline-centric. But this over many hospitals, not just over one, and get the data on ethically approved research projects out of the hospital realm back in the academic realm, so researchers actually get access to the data they need for performing this type of research. Of course, just healthy individuals as a reference are needed to compare what is different between what you get from clinical data to what you would expect as a norm. Of course, we will not throw away model organism data because it tells us a lot about things we just can't observe in humans, and we want to collaborate internationally, and this all needs a secure, interoperable environment to enable this type of research. So that's about the ecosystem we are trying to build in Switzerland as part of the SPHN initiative, which then in the end hopefully leads to new health innovation, either by directly changing the way treatments are done in hospitals or the usual way of publishing papers, bringing in new ideas from the scientific side. Now, as Peter already mentioned, that's not a walk in the park. There's lots of challenges ahead of us. It starts with, it's a complicated country. It's only 8 and something million people, but in terms of legislation, it's 26 semi-independent cantons, each having slightly different ways of running the healthcare sector, slightly different data protection laws. So if you want to shuffle data through the country here, it's not that easy. From a semantic perspective, dealing with 3 different languages doesn't make it easier either. So we have a bit of a challenge there. But this is on a country level. If we look at medical data specifically, there's other challenges. Now, you have heard about the FAIR data principles that everybody talks about in the open science range, most likely. I think in the medical domain, FAIR stands for forgotten data collection in some anachronistic format, completely isolated from the world with some residual information in it. No, of course not. It stands, of course, for findable, interoperable, and reusable data so you can use it for research. So interoperability in the health sector is a challenge. This is not what we would call fair data. And there's all kind of reasons why it's a challenge. Now, exchanging data has not only technical interoperability challenge, it has a lot of ethical and legal ones, and Christiane will talk about these aspects in detail in one of the next presentations. For SPHN, what we've achieved so far, we have one ethical framework under which all the SPHN partners operate, which is a big step forward. So we have a common understanding for what we want to achieve, how we work, and what are the principles under which we collaborate. Information security, we have the same issue. Everybody understands something different of what IT security should be. And we're very happy that we finally converged on the first SPHN information security policy a few days ago, that all the centers in the academic realm that treat healthcare data committed to operating under the same IT security guidelines, which was, knowing Swiss universities, a big step forward to agree on we are doing it on this way, and this is what we define as current state of the art of IT security. And then once we've solved all these problems, hopefully we got the data that gets analyzed by bioinformaticians. And there I just like to put a little footnote on what you might have seen from some big IT companies that make this claim of all the algorithmic problems are solved. Just give us the data, we pump it into our magic machine learning AI thingy, and it will solve all the healthcare problems. If you ask me, that's just bullshit, sorry. But a lot of algorithmic problems are not solved. A lot of work is needed to really understand the data, treat it appropriately, and there's a lot of work to be done here. And getting the data out of the systems and making it interoperable is not the end, it's the start of the game. Because nobody knows today how to make really sense out of these big, dirty data collections. Now, how do we go about it? I talked a lot about things which are challenging. How are we trying to address it? You've seen that slide from Peter. I think we're making very good progress on the hospital side. All the hospitals have started to bring their data pools together in data lakes where they're now able to get all data they have on one patient and start exporting it in a research usable format. On the IT side, we've established IT infrastructures at several universities that are operating under the same IT security guideline that start becoming interoperable. So for researcher, it doesn't really matter anymore which one of them they are using. The ETH has established a genome center in Geneva where project partners can sequence on a very large scale human genomes at a grade which is both suitable for research and for clinical applications. And there's a center for mass spec-based analytics in Zurich, and they're mainly focusing on proteomics and metabolomics analysis for finding new biomarkers, for example, as part of the driver projects. As Peter explained, driver projects are, from a technology perspective, our way to prioritize. Because if I build infrastructure, I always can build something which is really beautiful but really useless. So having scientifically driven priorities, saying this is really important for moving forward in that disease area, helps us to align the technical development of the various infrastructures to make sure we're making our investments in the right place and we're making sure this all fits together in the end and works. Yes, please.
Quick clarifying question. The biomed IT mills, do they provide
I'll come to that in detail. Let's start with semantic interoperability. Peter already mentioned it's a bit of a challenge, and what I wanted to show is how we use the driver projects to actually prioritize. If you want to say, we get all semantically interoperable on data variables, this won't happen before my pension because there's just too many. So what we're starting with is a slow step-by-step approach, saying we take the projects that now have started, we use whatever variable list they use in oncology and sepsis and have high priority. We make the whole country agree on using international standards. We approve them by our boards, and then we start implementing them, and then we make the next driver projects, and so on. So continuously, we start from high priority areas like oncology, like infection biology. We slowly move to lower priorities like broken legs or other things where personalized health might not have the highest impact. In terms of infrastructure, now coming to your question, what do the Biomed IT nodes do? Biomed IT nodes provide a secure, interoperable working environment at a university. They're not data pools. So the data stays, as Peter says, in the original location. The moment a project has ethical approval to get the data, it gets transferred into one of the Biomed IT node, and this is where people collaborate and working together. And we have chosen that kind of setup because if you have a multi-center project all over the country, you have to pool the data at some point so people can work, but it's not really one institution because you have researchers from different places, you have hospitals from various places that collaborate. So this is why there's this network of nodes that provide the environment, but it's not one centralized place where all the data resides, and it's not my home institution where the others have no access. So it's quasi secure, neutral ground where we all can collaborate. And then there's special data nodes, and this is where research data gets collected. Like if there is a core facility that generates large amounts of research data, you don't want to lose that in some study that then when it's closed is forgotten. So the Genome Center, for example, or the Proteome Center, they start collecting all the measurements they did in a research context and also archive them on behalf of the user so they become reusable later. Now, how do we make this all work together? Because a federated structure, of course, is much more complicated than what you would have if you could centralize. And the first question is, where is the data? And so what we're currently implementing is a system for a federated distributed query where each of the places where data actually resides, mainly university hospitals or data node, have a little adapter that can be queried from a central place. So you can ask the questions, how many patients in Switzerland that had a diagnosis of pancreatic cancer and were older than X, have an informed consent, and we have a blood sample in a biobank. So this kind of question you should be able to answer here. So you're not getting personal level data, so there's no data protection issue here. It gives you feasibility. Like, yes, I can do this study, and in Lausanne we have enough patients, or no, forget it, there's no way, there's just not enough data around. Now, once you've found the places where the data resides and you got your approval for getting it, the classical way is that you say, okay, give me all the genomes of a certain set of patients that have a certain diagnosis, and you bring it together in one of the Biomed IT node for analysis. That's the model how you would have done it in the past, or how you do it today. What we want to do tomorrow is a bit of a different concept. And this is, we want to enable distributed, privacy-preserving, federated analysis. And the idea here is that you don't bring the data to the researcher, you bring the research question in the form of an algorithm to the data. So the data stays where it is, but the algorithm travels to the data and comes back with the analysis result. Now, the reason we think this is an attractive idea is manifold. First of all, you don't have to move data. If it's too big, it becomes cumbersome. If you talk about intensive care unit data, that's terabytes per day, you don't want to shuffle through the network. But also, a lot of data you can't really anonymize easily. And in that case, you can't really share it easily. And if you move across country boundaries, it gets even more complicated. All these problems you resolve by keeping the data in a safe place in your home institution, and you only allow researchers to access it and analyze it, but not to take the data out. And like this, we can collaborate within the country on data which is not fully anonymized. And with this, we can also collaborate internationally with other countries because the data is not moving to another country. Now, of course, this all has a lot of technical problems, making it happen, authorizing the algorithm, checking that it does the right thing. It has semantic interoperability problem because you're working blinded. You're working on data you don't see, so you have to rely that the semantics are the same all over the place. But we think that's a very attractive model that is currently followed by many European countries because it also overcomes GDPR challenges and whatever goes along with it. And we had the first pilot running some weeks ago where we were able to exchange one of these containers and execute it at various universities in Switzerland and getting the result back. And manually it starts working, and now we have to make it technically more smooth. Now, as Peter already mentioned, all these projects have a lot of various components, and it's a bit like a herding cat exercise, and this is what the Data Coordination Center is all about, trying to keep an overview of where we stand with the various projects in terms of how does the semantics alignment work, how do the technical people work on interacting. So the Data Coordination Center basically doesn't do any of this technically. It's done by the universities, by the hospitals, but it coordinates the implementation and tries to find out, oops, there's something lagging behind, or here there's a standard missing, and trying to orchestrate that in the end this all actually fits together to one picture and not just a lot of pieces on the table. That's what I mentioned. I think I also mentioned a few times that we're trying to apply international standards as much as possible and not come with a Swiss extra solution that is different from the rest of the planet. That's why we're trying to engage with our international colleagues, and we're happy to host 2 important conferences on data standards in Switzerland this year. One is the Global Alliance for Genomics and Health meeting, which does the first time their annual summit outside of the United States, and it will be in Basel on October 3. And you're all cordially invited to join us there. And then a few weeks later, we're hosting the European I2B2 Transmart Users Group Conference. I2B2 Transmart is the leading open source academic platform for data exchange in the healthcare sector, and this will be hosted by our colleagues in Geneva on October 31st and November 1. Thank you all very much for your attention, and happy to answer any questions. Yes, please.
I have a cold, so I'm sorry, I have not a good voice, but I have one aspect that it looks really great and really complicated.
Yes.
And what I can understand is that this could be really useful today, because some patients, they go to one hospital, then they are transferred to another hospital, and then, oh no, they have to go to this other hospital because there is the expert for some disease. And the documentation most of the time doesn't follow. So basically, it could be like a first application. This could be used today. I mean, as soon as you have all the algorithms set up, you could still use your data for studying, for research, but you could implement that actively in hospital now, actually. I don't know if you plan on doing this.
It sounds like a good idea. In practice, it's something we deliberately keep our fingers away. First of all, there is the eHealth Swiss initiative, which is mandated by the BAG for doing this. The reason why I think we should keep our fingers away is because the speed of processes for information exchange for health care purposes is much slower than what we do for science. Because you're in a much higher regulated environment. If you want to exchange a patient record for treatment purposes, you have completely different requirements from a legal basis, from an IT basis, from an availability, from a how secure is the data perspective, because it's clear text. If you make a mistake, people die. So there you have to be very sure that the system you're building is rock solid. What you're trying to do here is a bit more on the opposite side. If you collect data from 1,000 patients and 5 of them you can't get because the system had a bad day, for science it doesn't really matter. It's more important that you're fast and that the data is accurate. But if you cannot access one of the hospitals at a day, it doesn't matter. They'll implement it later. So the way we work in the science field is much more on get what can be done today, but get it fast so we can move science forward, which is a completely different use case. So we're trying to separate the two things. Also, it sounds attractive in the first place, but...
Yeah, no, but because I think that the layout could be really made more efficiently what the BAG is currently organizing. I mean, I don't know. So
We're-
I don't know. Maybe you could work together.
So we have an invitation to present what we're doing at the BAG, not at the BAG we already presented, but at the eHealth Swiss Vorstand in October. So we'll see if there's areas where we can work closer together. But as I said, that's a highly regulated area where we have to be very careful not to tread on anybody's toes.
How do you see the involvement of industry in this? So I work for Novartis, as you know, and I'm just wondering, I see the research notes in universities and hospitals. Kind of what's the role that you would foresee for life sciences and so on industry?
So in terms of the scientific projects, it's open to have industry partners on board. So any scientific project that uses SPHN or that applies for projects can have industry partners on a, say, science project basis. We're also in contact with some industry partners when we discuss standards. Like we're talking at the moment with some people at Roche that build these analytics machines to help us get the LOINC code standardized, because, of course, that helps everyone then downstream. So I think there's interaction on the scientific layer, and then there is interaction on the side of standard setting. What we have not envisioned is something that other countries more on the US side are trying to do, kind of collect the data and sell it. I think that's clearly out of question. Scientific collaborations anytime. And we're currently launching another idea, and that I think what we're building there is basically a countrywide network that enables biomedical research. So I think industry partners should be very much interested in funding exciting pre-competitive research on that platform, because it really enables type of studies you couldn't do before. So we're thinking of what mechanism would work if it's kind of a foundation, or any mechanism where interesting research can be done on the infrastructure that we're setting up here.
Okay, cool. Let's discuss.
Hi, and I'm from the regulator here, so do you see any uses for regulation?
I think that's more a question for Peter, or? I'm the scientist.
Yeah, I think you should get easier to the data you need from the whole Switzerland. That's the other thing. Easier access to the data, and to have more data to make decision as a basis for your decision. I think that would be the big advantage. But for this, we have to achieve the interoperability. And then you're the lady sitting on the desk, and you can look and collect the data if everything functions well.
Maybe I can comment from a technical perspective also on what Camille said. Of course, it's the two systems. There is the eHealth Swiss channel, and there is the research channel. If you look under the hood, of course, the technology inside the hospitals, it's the same. You have to build your data lake, you have to standardize your data, you need to build your interfaces. So it's kind of dual use. So what we are pushing from the research side, the same is pushed from the BAG and the regulatory side, because in the end, we want all the same. We want to have the data clean, interoperable for different purposes. So I don't see this really as a conflict, but it pushes in the same thing, and then it's multiple channels where the data is useful for. So even if you don't use the research channel to get the data, still the underlying investment we do in the infrastructure is useful for both contexts. And Dieter.
One of the issues of the whole game is certainly the quality of data. So on one hand, you are pushing for semantics, which are used everywhere in the same way. What about the quality of the methodology? And for instance, a genome assay, I assume, is not the same quality wherever it is compared to the other place. Are you filtering somewhere this?
So that is a long discussion. Where to start? What we are trying to avoid is the term data quality, because in the end, data quality depends what you do with it. Data might be very good for one purpose, but completely useless for another. So what we're trying to do is not saying there's good and bad data and put a filter, but rather come with an indicator which says what's the variance or the precision or the accuracy I expect for this type of measurement. And then it's up in the application case to say, is blood sugar plus minus 5 milligrams good enough for what I'm trying to do, or do I need it more precise? So rather treating it as an as an attribute of the data than applying filters. But that still needs a lot of work to get it consistent.
Right, but there is another level. The people working, for instance, there's the Biobank initiative too, and they are working on the quality for biobank data. There's a lot of genomic work being done with respect to increase the quality of genomic data, which then flow into the system. But these are separate groups working on this.
I think what we have a bigger problem with data quality at the moment is not really on the measurement level, because there we can describe what happens, but it's on the interpretation and annotation level where we see huge heterogeneity. And there I think we still have to better understand of where this comes from.
So you mentioned the issues around data privacy and consent, which is obviously an interesting discussion. I think you're solving this the right way with the existing data. There's also initiatives like My Data and Health Bank that are doing it the other way, where it's saying center the data on the patient, and the patient aggregates and then consents to where can the data be used. Can this infrastructure be used to consolidate data on one patient? So could I go in as a Swiss patient and saying, instead of having a research questions for a certain disease area, I have one for me as a patient. I would like to pull together all the data on myself.
Yes and no. Oh. So, yes, in a sense of, from a hospital perspective, if you build your data warehouse and you have your exporters, then of course it's possible to export data also to things like my data. No, in a sense of what we're doing here, all works on pseudonymized, de-identified data. So the research data you cannot as a patient, but you could do the bypass saying me as a patient going to my hospital, getting the data out, and you can use the same interface, but it's the hospital who has to give you the data. We cannot, because we don't know who you are, and we're not allowed to know who you are. No more questions? I think we're running much too much over time, but I think the discussion was interesting. Next speaker on the agenda is representing our oncology driver project.